All Valcom VIP LD22 Series LCD displays require PoE++ power to achieve their full functionality. If PoE++ is not supplied by the existing network switch, a mid-span power injector can be used. Valcom offers such a power injector for this application, which is part number V-PI90. It's important to note that the Valcom LCD displays do not have an option for an external plug-in power supply. PoE++ is the only power option. On startup, the display alerts you if the required power is not being supplied to the unit. It'll power up, then a message will scroll that tells you so. Screen brightness, flashers, and audio will all be adversely affected by lack of power, so it's imperative to ensure that this PoE++ requirement is met. Valcom LCD displays are multifunction endpoints. They have internal speakers so they can deliver voice pages and other audio.
Testing 1, 2, 3, 4. Testing 1, 2, 3, 4.
They have integrated flashers so they can grab people's attention. And they have an integrated 22-inch LCD screen that functions as a clock when the unit is idle and can be used to deliver audio and visual messages from a Valcom interactive console or site manager. There are two types of programming required to do all these things. First, we need to tell the unit how we want it to function, which is what we'll cover in this particular module. Then we'll need to tell it what we want it to say by creating pre-configured messages in the aforementioned interactive console and site manager. We'll cover those steps in a later module. The first part of this programming is done using the VIP-102B Setup Tool. This tool is available for free download at Valcom.com. There's also a free, comprehensive online course that's highly recommended if you're not familiar with how to use the VIP-102B tool. From this point forward, I'll refer to it as the 102B tool for the sake of brevity. Assuming that you are familiar with using the 102B tool for assigning IP addresses, dial codes, audio groups, etc., in this module we'll focus on the setup parameters that are unique to the LCD displays and have not been covered in the online course. So let's jump into the 102B tool and have a look at those. Once we've scanned our LCD display into the 102B tool, we'll select it from the device tree. From the Summary tab, you'll notice that from the factory, the unit will DHCP an IP address if the network's configured to allow it. If the network doesn't allow for DHCP, the unit defaults to the factory IP address, so you'll need to assign one manually. Obviously, this will need to be within the range of available addresses on your particular subnet. In the version detail box of the Summary tab, you can see the minimum power required for this particular device. However, the tool does not tell the device how much power it's actually being supplied. Here's why that's important. Most modern network devices use something called LLDP, or Link Layer Discovery Protocol, to tell other endpoints what their capabilities are. One of the capabilities that a PoE switch would send via LLDP is the amount of power that it's supplying. But, as mentioned earlier, if you're installing on a network that doesn't have a PoE++ switch, you should use a mid-span power injector. Trouble is, these power injectors don't use LLDP. Therefore, even though the unit is getting the power it needs from the injector, it would still assume that it's underpowered because it isn't receiving LLDP information. The result would be that a low power message would appear on the display. The good news is the 102B tool provides a fix for this. If we go to the Sign tab, you'll notice that there's a box for Assume PoE++ power source provides maximum power. Checking this box tells the unit it's receiving PoE++ power and prevents the low power message from appearing. Also in the Sign tab, you can select the language of the display. This will change the month and day abbreviations to the specified language. We're currently offering Spanish, French, and English. Next, you can select either fixed brightness for the display or timed brightness, where the display changes based on a schedule that you assign. This comes in handy if the device is installed in an area where the lighting changes significantly at the same time every day. For instance, the lights in a common area near patient rooms in a hospital might be dimmed at night to allow patients to sleep. You could set the display to correspond to these times. One of the things that the LCD display can do is change the look of the screen based on the type of alert that is sent to them. Adjusting the alert priority threshold controls this. So if the threshold is set at 50, any alert above this threshold will cause the template that appears to change and stand out from the normal display. We'll talk more about these templates in the Site Manager programming module. By checking the Custom Background Image box, you can upload a custom background image that will replace the plain background that you see here. The required size is listed in the pop-up menu when you click Upload. We'll choose an image of some mountains for our example. Our image is already correctly sized, so all you have to do is select it. Then click the Upload button, confirm the upload, and wait for the 102B tool to tell you that it's ready. Just like when you change any other parameters on a device, you'll need to push an update to it once you've finalized all of your changes. You can also upload a custom logo image by clicking the box and following the same process. You'll notice that uploading a logo has different size requirements, so make sure that the image that you want to use is sized correctly. We'll select a Valcom logo, click Upload, wait for the confirmation, and again push an update. Here's where the logo will appear on the display. As mentioned earlier, when the unit is idle, it displays a clock. In the Time tab, we'll define how that clock will get updated to always display the correct time, and we'll customize what it looks like. The NTP selection order dropdown defines where you want the device to look for its time correction. Again, when first powered up, the device will use DHCP to obtain an IP address. The NTP selection order is also defaulted to DHCP, so the unit will immediately display the time it receives along with its IP address. But DHCP is not designated to function as a time synchronization protocol, so it doesn't send recurring time updates. For that, you'll need a static NTP server, which you can enter here. If you'd like the unit to only look at the NTP server for time correction, you can select that option from the dropdown. If the unit isn't receiving time updates, this flashing red box will appear in the upper right corner of the display. That box completely disappears if the unit is receiving time updates from an NTP server. Next, we can select the time zone and any additional offsets if desired. The next settings have to do with what the clock on the display looks like. The clock mode dropdown allows you to select what type of clock face is displayed. The default is a digital clock, but you can also change that to analog or both. You can also change how the date is displayed using the date format dropdown. Selecting none will remove the date from the display. The time format dropdown allows you to select 12 or 24-hour digital formats, with or without seconds, or military time. If you've chosen the analog clock mode, you can change how the face of that clock looks, from round, square, or custom. Just like uploading a custom background or logo, the image size requirements are listed in the Upload Custom File dialog box. To create a custom clock face, start by downloading one of the blank clock faces in the Templates section of the Products Resources page of the Valcom website. There are several methods and programs that you can use to customize your clock face. We'll demonstrate by using PowerPoint since it's widely available. Start by adding the blank clock face PNG image to a blank slide. Then add a logo or picture, also in PNG format, and position it on the face as desired. Select all the images at once, right-click, and select Save as Picture. Give your customized clock face a name and click Save. Resize the image if needed to 1060 by 1060 and save it. Select the file, click Upload, wait for the 102B tool to tell you it's successful, then push an update. From the Flashers tab, you can specify how and when the flashers on the unit will function. Starting from the top, if the unit's configured as a talkback device and you check the Flash on Intercom Calls box, the flashers will fire when the device receives an incoming intercom call. This is different from the device receiving an audio or visual announcement or voice page. those can be configured using the next 3 checkboxes. We'll skip this one for now and come back to it in just a second. By checking the Flash when audio pages are active box, the flashers will fire when the device receives an audio page above whatever priority level is selected from the dropdown. For example, let's say we've checked the box and we set the priority level at 25. If an audio announcement is sent that has a priority level of 20, the unit will play the audio, but the flashers will stay dormant.
This is a voice paging system test. 1, 2, 3, 4, 5.
If an audio announcement is sent with a priority of 30, which is obviously above 25, the unit will also play the audio and the flashers will fire.
This is a voice paging system test. 1, 2, 3, 4, 5.
The same applies for visual messages. When the flash when text pages are active box is checked, the unit will flash whenever it receives a visual text message above the selected priority. Now let's go back to the flash based on individual group settings checkbox. Checking this will override and hide the 2 we just discussed and give the option to set global flasher group settings. Notice that you can adjust settings for all global devices or only this specific device. The audio groups that this device belongs to, which you would have set when you assigned IP addresses, device names, dial codes, etc., will have a check in the box to the left of them. You can adjust the settings for those or any of the groups by clicking on the pencil icon. In the dialog box that appears, you can set the flasher pattern of 1, 2, or 4 seconds, or steady. You can also set the flasher color by entering a desired RGB value, or use the color picker. Then, whatever message or announcement is sent to the group, the flashers will behave according to the settings that you gave them. You can disable the flasher test that fires on boot if you check this box. You can also adjust flasher brightness of this particular device between the levels of 1 and 10. You can see the default is 6. So now that we've programmed most of the basic functionality of our LCD, let's move on to building messages that we can send to it in the Site Manager and the Interactive Console.